Okay, here I am with my mask, right? And we're going to start the notes for today. So in case you're absent, I'll get myself out of the picture here. There was a nice introduction. Okay, Nathan, what should I do first on B is where we're going to go. What do you think? Yeah, so hopefully you mean distribute, which is part of simplification. And then what should I do next? Yeah, so what am I going to do? Tell me exactly what I'm going to do to both sides. Put it in those terms. Okay, add 7 and add 10x. Awesome. No matter what method you end up choosing, and by the way, that is why the ed puzzle that I have that I'm telling you, well, you need to watch, it's actually review, but also it's a big smattering of questions, and now you have to start choosing which method to use to solve. Unfortunately, from what I've seen in the quizzes, some people don't know the last two methods at all. Even though we had a whole chapter on factoring, that's why I want to beat my head up against the wall. A whole chapter on factoring, and we still don't know how to factor. It's just not good. All right, but now we have to start making decisions. When I see a question, how should I solve it? Well, it doesn't say that here. It says use the quadratic formula, so it's direct. And I imagine on a next quiz or test, we will have sections that say do it this way, so we want to see that way worked out. Then there's going to be questions where choose the best method, and if you don't choose the best method, you're going to run out of time on our test. And that's what the ed puzzle is all about, and that's why it's so important. Okay, all right. Good. I think that's good enough for your representation. You're nice. 25, Damien. What do I do next? I could say your first name and not get sued. So what's the quadratic formula? Yes, you may. Okay, we'll wait for you because we need this time to actually make sure you know what you're doing, but also, the action of you talking about it in class actually spurs your brain. So what do we got? Okay, let's start using numbers instead of giving me the quadratic formula. There you go. The opposite of B. Okay. Good. All right. B squared, 4 squared. Yes. Okay. All over. 2 times 1. Hey, did I play this for you, by the way? Where's the calendar? Did I play this for you last week? No? Okay, here we go. All right. Someone smile, please. Hey, you can play this all day long until it sinks in your head. Anyone? Anyone want to sing along? Yes? You want to sing? You said 80? You want to go ahead? No? Oh, well, you went like this. Usually a teacher sings this. I may sing it in the future. All over 2A. Okay. You can do that all you want. It's right there, man. Okay, and then you'll have it memorized because you have to. Sorry for pointing in your face. Okay, you have to have this memorized. All right, we ain't got time for this. -4 plus or minus. Okay, I'll take it from here. Oh no, 16 minus 28. Is that -12? Is that correct? I'm trying to remember from yesterday. Okay, you know what? I'm gonna get somebody else. Hey, what's the square root of -12? Student number 21. Oh, I gotta count. 18, 19, 20, 21. I think that's Isabel. Okay, what's the square root of -12? How do I break that down? Okay, and then what about the negative? Okay, so what does that end up becoming? -4 plus or minus 2. Nice. Awesome. Okay, and you're done. Good. Just want to make sure you remember about I numbers, okay, in this weird world that exists. Okay, and then the last thing is we should split this up into 2 separate fractions. This becomes -2 plus or minus 1 root 3i. This cancels. Think of this as split it up into two fractions and how it reduces. Hopefully you can start skipping steps. That only comes from practice. So on and so on and so forth. Okay, good. So there's the quadratic formula. Okay, now I have some discovery, and this is going to take a moment. So I want you to give this a try before I start talking. We're going to go back to graphing. We had a whole chapter on graphing. Okay, so find the vertex of the following quadratic, then use the quadratic formula to calculate the zeros of each quadratic. Finally, possibly we'll find 2 more points, maybe not. It depends, what we have going on here. So take a minute to try to do that and try to remind yourself, because that is something we got a whole chapter on, and we should know where we're going on that. Let me check my time and see if I'm wasting too much here. 9:13 is our time, so. Yeah, I think I'm going to go ahead and get a student here, get you warmed up here. Student number 19. That's not that is a repeat. Nathan again. Hey, Nathan, what's that formula that allows you to find the vertex of this particular situation? Nice. And did you notice negative b over 2a is in the quadratic formula, like the beginning parts on the bottom? There's a relationship there. Okay, there is. But what is negative b over 2a? So here's the vertex. What are the numbers that you're going to put in for that? Okay, good. Negative 4. He said 4. Go ahead. Over 2 times 2. And hopefully I don't have this too small where we can't see it. Maybe I'll move in on that and we'll jump back to the graph. All right, what does that become, Nathan? And then what do you do about the y-coordinate of the vertex? Plug it in. Nathan, you're on fire right now. Calculator's doing well for you. You know what that becomes? See how good you are with the calculations. Because we should be able to mentally plug it in, especially when it's just 1. Nice. Okay, awesome. We are floating along here beautifully. When I'm asking questions and we get answers that quick like that, that's a positive reinforcement for Mr. Samuels. All right, that shows that Nathan is on track and everyone else that has been called right now. 18. Nice. Aiden, you can either answer this question or sing the quadratic formula song. What do you want to do? Okay, answer the question. Hey, what's the y-intercept? Oh, no, the vertex is 1 common negative 8. What's the y-intercept, especially when you're in this form? Wrong. Why would I say wrong? You got to make it a coordinate. I don't want to scare you. So what is the actual coordinate of the y-intercept? 0, -6. So I gave you a wrong just to scare you so that you put your answers in the proper format. And then you remember this, Aiden? There's an axis of symmetry, so it also should be 2, -6, right? Okay, so that's how we can get these extra points. And then the quadratic formula. Let's see if you're paying attention, man. This is flying along here. Student number 26. Nice, Raymond. Hey, do the quadratic formula, and then we'll tell you that those end up being the x-intercepts. Zeros, x-intercepts. So what's the quadratic formula for this situation? And tell me with the numbers, just like I made Damien do. Like, don't give me the quadratic formula of letters. Start putting the numbers in. No, the quadratic formula is the opposite of b plus or minus the square. So that's what we, coming in here, that's the last thing that we just taught and did. And actually, 4, the opposite of b, got it? It'd be -4 squared. Hopefully you luckily, you do know that, but what's -4 squared? What does that become? 16, and hopefully we do start doing that. We start doing the calculations mid and save some time. Yep. Yep, 2. Or times -6, good. All over, good, you're going. 2a or 4, yep, so I put 2 there because you were, yep, all good. How you doing over there, Sean? Fine? Taking notes over there? Uh-oh, that's a lack of response. Hope so, dude. 16 minus a negative. This is minus a negative. 4 times 6 is 24. Times 2 is, I can't think. 48, 50, 64. Hey, Sean, what's the square root of 64? So this is 4 plus or minus 8 over 4. What does that give you for your two numbers for this? Hold on. What's 4 plus 8? 12. What's 12 over 4? 3. Okay. And then what's 4 minus 8? -4. What's -4 over 4? -1. Let's say and. What does that make 3 and -1 for this graph? I actually just said it before this. The zeros or the, for the graph, x-intercepts. You're done. So 3, 0, 1, 2, 3, and -1, 0. Boom shakalaka. Whoa. Okay. All right. So let's sorry. I'm okay. It's not COVID. Sometimes as I'm talking, I get kind of like a little scratch in my voice. All right. So just look at that square root of that. Look at what happened with this graph, and then let's go to the next one. Okay, so this is called an extrapolation, but also we're getting a lot of review because there are going to be things that we're going to come back to that you're supposed to know from previous chapters. Okay, and we're going to go right to a student here. Maybe. Boom. Student number 21, 26, 24, 23, 21. That was you again, Isabel, right? Nice. Okay, what's the, what do you notice that's the same in this question? Compared to the last one, hopefully you did write it down. I think you did. Yeah, so what do you think the vertex's x-coordinate's going to be? 1, but now we got to be careful. 1 comma what? Go ahead and plug it in and tell me what you get when you plug it in real quick. Okay, so what she said was it's the same a and b value, so negative b over 2a is going to be the same. So we're going to get the same x-coordinate of the vertex. Got the y-coordinate? 0. Okay, and now something special has occurred. 1 comma 0. Oh, we're right on the x-axis. All right, and then I'm wondering if I have enough time for this, because actually the end of the notes are pretty quick, but we also do have to do the quiz thing, which really is just passing it back and figuring out who has to come today, later. Layla? Okay, let's do and jump to, first of all, what's the y-intercept? 0 comma 2. And then because of the axis of symmetry, okay, and then real quick on the quadratic formula. Go ahead and throw in the numbers. Tell me the numbers for the quadratic formula. -4. You were about to say that, right?
Yeah, plus or minus the square root of -4
squared, which is what? 16. So hopefully we can, as we get used to the formula, we can start calculating as we shove numbers in, right? All over. Oh, it's 2 times 2. All right, 2 times a. So make sure we got that. And you do have to have this memorized. That's why I put that stupid little song there. If you start singing it at home, you'll actually start memorizing it, right? And your parents will think, or guardians will think, what is going on in that room? Hey, at least ain't that rap music. I'm just kidding. Not saying anything bad about rap music. 4 times 2 is 8. 8 times 2 is 16. 16 minus 16 is 0. What's the square root of 0, everybody? 0. What you get out of this is one answer, and there's exactly a reason why. It's because the vertex is the x-intercept. So that's why these correlate to each other. That's what I was talking about, negative b over 2a. This ultimately became negative b over 2a because this is nothing. All right, there's nothing in there. So the x-intercept is 1, 0, and it's right there. So you know what? We don't have the time. Usually I'd make you try to find one more coordinate by input-output. If we don't know how to input-output still at this point, boom. I just want to bang my head up against this cabinet. All right, but we're just going to go ahead and move on. And then the last one I'll take, and I'll leave the students alone just because of time. But what do we notice yet again for this one? The same what values. The same what values on this last one, because we're extrapolating, making a point out of this. A and B. So what's the vertex's x-coordinate? Vertex's x-coordinate is 1 again. Negative b over 2a will give me 1. And then real quick on plug it in, sorry. Pretty simple because it becomes 2 minus 4 plus 4. Minus 4 plus 4 cancels when you plug in 1 for x. Should be simple to evaluate for that, me talking about this. And you end up getting 2, 1, 2. And then the y-intercept, we're not going to write it down. We're just going to graph it, is 0, 4. The c value when you're in this standard form, the stuff that you're supposed to remember from previous sections. And then what's going to happen when we do the quadratic formula? The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Did I at least sing it when I taught it or no? Yay! All right, so I found a better version of more professional people, better singers than I. X equals 4 plus or minus, oh no. 4 times 2 is 8. 8 times 4 is 32. 16 minus 32 is negative 16. Everybody, what kind of answer is this? Starts with an I. Imaginary. We got I numbers. This ends up being 4 plus or minus 4i over 4. And then when you split this up into two separate fractions and reduce, this ends up becoming 1 plus or minus 1i. And the reason this happened is because what's happening over here? What does not happen with this graph? Doesn't cross the x-axis. Okay, so this little extrapolation had the same parabola that I, through different numbers for the c value, kind of shifted it up and down. And then we analyzed what happened with the quadratic formula in those cases. Right now we are in cats with my seniors, and we're dealing with polynomials, x to the thirds, x to the fourth, x to the fifth. In fact, we're going crazy. Some can be even higher than that. And always at a particular position, if it doesn't cross the x-axis, the zeros end up being imaginary at that little position where we have a turn in the graph, but it doesn't actually hit the x-axis. So that's something to remember. All right, we're not going to write this down because of time. What are the similarities among the graphs? Same x-coordinate vertex. Axis of symmetry is the same. The vertices are close to being the same. The y-coordinates were a little different, and that's how we got some that were shifted up or down. Examine with the quadratic formula for each section. What portion of the formula indicates the number of real zeros or number of imaginary zeros, and so on and so forth? It is this. You don't have to write this down yet. I'll write this down when we talk about what's called the discriminants. Okay, and then don't think of this as a bad word. Sure, it is with humans. When we discriminate, we put people into categories, and then that turns into racism, or so not maybe necessarily that, but just when you treat people like that, discriminate in a discriminate way, it's bad when you categorize people without even knowing them. All right. Well, in this case, it's just about numbers, so we're okay. Numbers aren't going to be mad about this. That b squared minus 4ac discriminates or categorizes what kind of solutions you're going to have before you actually find the solutions, because it's underneath the square roots. So write this down, that this is the discriminant of the quadratic formula, because it is that part that determines what kind of solutions we are going to have. Therefore, will we have x-intercepts or not? And actually, I think I'm going to go ahead and expedite this, because I have a chart from Mr. Stronowski, who made this, that actually breaks this down. So I'm going to actually go to the chart and have you put this in chart form. So here we go. This is what I was about to write. When b squared minus 4ac was greater than 0, that was our first example. What do we call that? I forgot what these, 1, 2, and 3. So that was number 1. Number 1, b squared minus 4ac was 64, actually a nice perfect square. And what ended up happening with that was we got nice, perfect little rational zeros. Actually, these are integers, a little bit better. Rational means fractions. They can be expressed as fractions, and I hope you've been, taught that in previous classes. But that is number 1. That was our first example. The value of the discriminant was positive. And then I have 2 conditions on this I want to write. All right, but here's what happened with the graph. It actually crossed the x-axis twice. So the number of solutions, okay, now here's where we're going to write a couple of different things here, okay? But the solutions are 2 real solutions, and therefore turn into 2 real x-intercepts. Big concept, okay? Again, we're using this in CAT 2 years later. Types of solutions. Okay, well, let's break it down even more. In our example number 1, we had a perfect square. Whenever you have a perfect square, the zeros are actually rational. And I don't have too much time to discover that, but rational is a nice fractional answer. Perfect square, you square root it, you get a free number, then you're able to evaluate it and get a nice number that you can put on the coordinate plane without your calculator. The other problem is if it's a non-perfect square, and I should separate these, non-perfect, well then that's irrational. That's when you get a square root of 12, let's say. You can bust out stuff on that, but you still have a square root left. To really find where that's on the x-intercept, you have to go to your calculator and get the decimal. And I've had you do that once, calculating decimal approximations of square roots. Okay, this was number 2 in our examples. When the discriminant equaled 0, that is because the vertex was right on the x-axis and you only had 1 0 there. So the number of solutions is 1 real. 1, and I guess real is what we put here according to how this chart goes. But you can just put 1 real. And when the value of the discriminant is negative, and it doesn't always have to be going up. I'm kind of emulating what we had for examples here. So it could be going down and the vertex is below. That would still be a situation where I would have 2 imaginary zeros. They'd have I numbers because you're not crossing the x-axis. Okay, so the number of solutions is 2, and this is where you get imaginary solutions. I believe on the, well, I shouldn't, it's kind of cheating, but I did kind of sneak through the SAT exam and kind of flip through it. There's a lot of parabola questions, and there's a lot of questions, or at least a handful, about zeros and so on and so forth, this concept. Okay, this is really what happened in number 2 in our examples. And I do want you to kind of write this down. Maybe not all of this, but in the future, and we are doing this huge with CAT, the idea of a double root. So I guess I should go back a little bit before, the example is going to be super fast, really fast. So this is number 2 in the example, when I had a vertex right on the x-axis. what's happening behind the scenes is you actually have what's called a double root. So I do want you to kind of read through this. All quadratic equations have two solutions, whether it be real or imaginary, and even the one solution counts as two, because one unique root, when a quadratic has one unique root, it still has what's considered two solutions because there's a double root hiding in there. So what's hiding up in number two is, if I factored and looked at that, I would have a binomial times itself. So I'd have a zero that happens twice, but that's only one x-intercept. It really is only one zero, but it happens with a multiplicity of two or a double root. And I'm going to write that down too. We don't use the term double root in CATS. We use multiplicities because we have zeros that have a triple root or a quadruple root, and it goes on forever. We could have x minus 4 to the 5th power. That's a root with multiplicity 5, and the graph behaves a certain way with that when it goes through. So we'll allow that. This is really a more specific term. And I'm going to go up to that real quick before, well, I guess I don't have the time, okay, because I got a lot of things I got to do. Okay, so now look at what this says, and pay attention to your homework, because the homework is all of 5-3. I don't know how many questions, 10, 15. Some of them say use the quadratic formula and solve it up for everything, and some of them say find the discriminant, and you need to be able to figure out the difference between questions. So here it is. Find the value of the discriminant. Say the number of real imaginary. If the solutions are real, are they rational or irrational? Okay, so it says find the discriminant, which just means find b squared minus 4ac. So whenever you see that question, just find that part. So b squared is 144 minus 4ac. And no, you don't want to put the square root on it. You just want to analyze it, then think, what if I was going to take the square root of this? What kind of answer would it be? 4 times 2 is 8, times negative 2 is negative 16, minus a negative 16 is plus. I believe this becomes 160. First things first, is 160 a perfect square, yes or no? 144 is a perfect square. What's the next one? What's 13 squared? Come on, someone knows 13 squared. 169. So is 160 a perfect square, yes or no? No. So it is, say the number of real or imaginary two real solutions. If they are real, what will they be? They will be irrational, because you have a leftover radical. The only way that you could graph the x-intercept is to take the square root of 160 physically on your calculator and get the decimal. And that's it. When they ask you the discriminant questions, what type, you don't find them. You just tell us what kind they would be. Okay. B squared, here we go, 144 again, minus 4ac. What to do is 8. 8 times 20 is 160. 144 minus 160 is negative 16. What kind of solutions would we have? What kind of solutions would we have? Two what? Imaginary. If we went ahead and kept going, that's exactly what we had in our example up there. Square root of negative 16. And then that doesn't apply because they're imaginary. Well, hopefully I can get these out to you real quick so that you know who's coming. Jacob, okay. You do not get to keep these. Actually, you're son of a nutcracker. Okay. The time. Abby O'Sullivan. Abby, great. Help me on this. Natalie Maka. Okay, good.